So this will be a rather quick tutorial since I am already gonna assume that you know a lot of basics and stuff. And these basic stuff is, well, Git, you have to know about Git, and you also have to know about SSH. Have some basic understanding of Linux, basic network understanding, ports, DNS, and so on. And obviously you have to understand what cloud is, since we're gonna build this in AWS. And you have to understand what Docker is, virtualization, and the Docker file and build and such of. Also an understanding of CI/CD and CodePipeline, CodeCommit, CodeBuild, ECS, and EC2, and an understanding what a load balancer is and what the purpose it fills. So basically, this tutorial is mostly for someone who already knows all these things and you just want to put all the pieces together to build something that you would actually use in the real world. What we will be building is a sort of pipeline and we will be using only AWS tools to do this. And the pipeline will also deploy the newly built code into ECS cluster. And the ECS cluster is going to run on EC2 instances. And so each EC2 instance is going to have 2 Docker containers running inside of it. And I'm sorry, but my drawpoint.io skills are kind of bad, so this is as good as I could make it. But anyhow, each Docker container is going to be running on different ports, and the load balancer is going to be listening. It's going to be dynamically linked to each container, so in a secure manner. So it doesn't matter which port a container is running on, the load balancer is still going to be able to hit it and serve our application to the internet. So how this would work is a developer will push the code to CodeCommit, which is AWS, basically their own version of GitHub. And this will trigger that the code pipeline, once we have pushed code to the master branch, it will trigger the pipeline to build our code. And the CodeBuild is going to then push the code or the build code images to our repository, the Docker repository, and in this case we're also using AWS own version of it, which is Elastic Container Registry. And after that, the code pipeline is gonna go ahead and deploy it, and it's gonna go to the registry, pick the new image that we just built, and deploy it to our cluster of EC2 instances and that has running our containers. And then we'll be able to see it lively here. And so, anyways, to get to it, we are going to start up with creating a user for this project. So head on to IAM, users, add user, and give it programmatic access. I'm going to attach some policies to it. The first policy is going to be CodeCommit full access here. And we're also going to have EC2 container registry. Container registry power user is sufficient for this. And I think that was all. Yeah, that was all. This is obviously optional, but I like to add tags when I do these kind of things just to keep it clear of what project I'm using it for. And it also makes it easier to clean everything up later on. And we can go ahead and create user, and we're gonna have to save the access key and the secret key so we're safe. So we're actually not going to use it. I don't think we're going to use it in this particular scenario, but I'm just going to save it just in case. But go ahead and save it if you want to use it for whatever other purposes. Because if you don't save it at that point, you won't be able to retrieve it later, and then you have to create a new user and redo everything. So might as well save it. Anyhow, next step is that we're going to generate some a key pair, SSH key pair. So hit in this command, and I am gonna use the 4096 bytes. Yes. Yeah. can name it, well, we're just gonna name it YouTube. No passphrase for me. So there we go. Yeah, we have to go. Oh, there we go. And we have to copy the content of the public key. Here we go. And we go to our newly created user. And go to security credentials. Upload SSH public key. Paste it in here and upload it. And now we need to copy this SSH key ID. Let's see here. Yes, what we're gonna do now in our local.ssh directory, and we need to create a file called config. And here we're gonna enter host, which is gonna be git CodeCommit dot and then AWS.com. And this will allow us to use git CodeCommit on any region basically. And next on we're gonna use user, and here we paste in the SSH key ID, which is what I just copied here. And then identity file, which is gonna be, for me at least, it's gonna be root.ssh.youtube. Identity file, yeah, I spelled it correctly. Alright, that is it, and then we can just go ahead and save that. And now to step 2 is to go to CodeCommit, and we're gonna create a repository. And just click on create repository. Just gonna name it YouTube like everything else. Here we go, and yeah, this is it. Now we go ahead and click on SSH. Oh no, my apologies. Clone URL in the right corner, then clone SSH. And now we need to go to our right. Here we are. Now we need to initialize. Oh, right. And let's see here. Git. Wait, let me just check that. Yep, got it all. Right. And wait. Oh, right. I'm just gonna say, I don't know. Okay. All right, now we can git remote add origin, and we can paste in the SSH URL and git push u origin master. Yep. Yep. And there we are. Now we can, if we go to our repository, we should be able to, yeah, we can see all the files here now. So on to step 3, which is gonna be Elastic Container Registry. Here, repositories, create repository. We can make it private, I guess. YouTube. Yeah, everything's good. Create repository. And Right, now we need to actually copy the URI, and we're going to add it to a file that we have in our local Git repository in the demo app here. And that file is called image definitions.json, and it looks like this. So image URI, you just paste in the URI, and I'm just gonna add a latest tag, and that is gonna be the default tag for most of the time. So, but if you have another tag, you just add that. And so there we are done with the ECR step. So go to step 4, which is gonna be CodeBuild. Now we're gonna create a build project. Go ahead and add a name. There we are. Source provider is gonna be CodeCommit, and we're gonna use the YouTube repository, and we're gonna use the master branch. And we're gonna use the manage image. We're not gonna use a custom one. We're just gonna use something that AWS provides to us, and I'm just gonna use Ubuntu. I think it's the one I've always used, and it's just easier to stick with what you know. And runtimes, standard. Image, always use the latest. Well, that depends, I guess, but I'm gonna use the latest. I know that for a fact there is actually quite a bit of differences when it comes to the build spec file if you use 4.0 or if you use 5.0, but I'm just going to use 5.0, and if you follow along and use my files, it's going to work out with 5.0. Image version, we're just going to use latest, which is going to be, yeah, it's going to be this one. Let's see here. Yeah, this one needs to be checked, otherwise you can't build Docker images. And we're just gonna let it go ahead and let it create a service role for us. And actually gonna copy this because it's gonna lose that later. And let's see here if there's any. No, we don't need any of this right now. And we're gonna use a build spec file, and we're not going to add any artifacts right now. We're going to do that later on. And yeah, looks good. We can go ahead and create the project. Gonna go ahead and go to IAM again, because we just need to attach some permissions to the newly created role. Let's paste it in. Here we are. And we can add permissions, and then attach policies, and then we can attach Container Registry, full access. Here we go. Attach policies. All right, we can go ahead and use the build spec file. So basically what happens in here is it's just going to wait for Docker to be running and before we go ahead and do anything. And what it does, this part is basically getting the password from the ECR, and then we're piping it to the Docker login command with the std in. So we just need to add our region and then the ECR URL. Just gonna go ahead and copy that, and just gonna paste that. Wait a minute. Actually, it is a URL. Wait a minute. Or is it not? Okay, well, either way, basically this row here is the exact same row over here. So what you could do is just copy this whole thing and paste it in, but I'm just gonna copy this last bit. And oh yeah, we need to add the region as well. Yes, and yeah, here we need the URI. And before you add the tag that you're gonna use, and the default is latest most of the times, but you just add whatever tag you're gonna use. And same here. And since every time it pushes, it's gonna add tag latest, so it's just easier to keep it that way for this demonstration. All right, I think that is all here. Yes, that is it. And I'm also gonna go ahead and show you the Docker file. So basically what it does is install Apache and copy over the index file to the image, and yeah, it's just gonna run the Apache server when we launch it. That's about it. And we can go ahead and add everything. No, wait. There we go. Let's see here. Next step, we are gonna create the load balancer. And that's a EC2 feature, not a light sail feature we're gonna use. And we're gonna use an application load balancer because that is the load balancer that can actually work on dynamic port range. It has to be internet facing, of course. And to achieve high availability kind of architecture, I'm just gonna go ahead and use each subnet here. Okay, right, we have to create the security group. And I'm just gonna call it YouTube like everything else. Actually, you might need to allow inbound HTTP. There it is. We're just gonna go ahead and do that. Well, so deleting this inbound rule was actually a mistake. I thought we would do this in a later stage, but that wasn't the case. So go ahead and add the inbound rule here. Actually, we're gonna do that later. Oh. Now if we refresh here, we should be able to find, yes, YouTube. We can remove that one. There we go. And yeah, this is why I didn't add the inbound rule, because we're gonna add what port and everything is gonna be listening to at this part. So that's why I didn't add the inbound rule. And we can have instances checked, and we are gonna use the HTTP protocol. And for health checks, it's just gonna be slash. Yeah, that's oh yeah, I'm just gonna add a tag. No, wait. There we go. And quickly click next. When we come to register red targets, we don't have any targets right now because we haven't created a cluster or anything. So we can just go ahead and create target group. And there we are. We can just close this. Yeah, close that too. Refresh here. And there's our target group. And just gonna add a project tag. And go ahead and click create load balancer. There we are. So now to step 6, which is going to be creating the Elastic Container Service. So navigate to ECS. Yeah, it's going to prompt you to press get started over here, and then it's going to take you to use, I think it might force you to use Fargate, but we're not going to use Fargate. We're just going to actually launch this on EC2 instances. So you have to press clusters on the right, on the left, and then create cluster. And we're going to use EC2 Linux Net plus networking, like I said. Can have on-demand instances, and I'm just going to use the T3 micro because they are free, or almost free. We're going to have 2 instances running, and we're going to use the latest Amazon Linux MAI. And yeah, we have to create a key pair. I already have a bunch of keys, but I'm just for the sake of this this tutorial, I'm just going to create one. And yep, everything else looks good. Create key pair. There we are, and then we just save the file. And of course, save it somewhere safe. And then when you've done that, you are gonna wait, where is it? Oh yeah, I have to refresh here. Yeah, here it is. I'm not gonna use that one. I'm just gonna use another one I usually use, but you can just go ahead and use the one you just created or another one. Yeah, we're not gonna create a new VPC. We have to use. We're gonna use the default one. And here, like before, to achieve high availability, I'm just gonna use all 3 subnets. Yeah, everything else we can go ahead and leave it as a default. And hit create, and that is gonna go ahead and create the cluster for us. There we are. Now we can view our clusters. Yeah, right. We have to go to task definitions now. Create a new task definition, EC2, next up. Everything's going to be default, and we're just going to set how much memory we're going to use and how much CPU units. This depends on how large our EC2 instances are. And then we can add a container, and I'm just going to give it the usual name. And now here we need the URL to our container registry. Where is it? Oh, here. There is the URI. And we're gonna go ahead and paste that and add the tag. Set the hard limit to 300, which is the same as I gave it over here before. This means basically it's just gonna kill the container if it exceeds 300 megabytes. Host port, leave it as blank, which means it's gonna be listening on anything, basically random. And container port is gonna be 80, because that is the default port Apache listens to. And everything else is gonna be the default, and we can just go ahead and click add. Everything else is also gonna be default. Yeah, by the way, save this name. Everything is default, and just click create. Like before, we have to go to the image definitions, and we have to add the container name here. There we are. And now we need to go to our clusters, the cluster we just created. Under the services tab, we have to hit create. Launch type is going to be EC2. We're going to use the task definition we just created and use the latest revision. And use the cluster that we just created as well. It's going to have to use replica, and number of tasks basically means how many containers do we want to run. And we have 2 EC2 instances. So if I put in 4 tasks, what it's basically going to do is going to distribute 4 containers equally to all EC2 instances. So we're going to have 2 containers running on each instance. If I were to have 6 over here, then it would be 3. If you were to have 5, then it would give 1, 3, and another 2. If I had more instances, then it would just distribute them all equally. Anyway, minimum health checks %, just leave that at 0. And let's see. Yeah, everything else is going to be set as default, and just go ahead and click next step. Now it's time to add our application load balancer. If you don't have an ECS service role already here, then you can leave it as create new role. And this installation wizard is just going to go ahead and create that role for us. Yeah, that's the load balancer we're going to use. Yes, this is the container, and yeah, add to load balancer. And then we're just gonna use the AT HTTP. Let's see, target group name, and just leave it as create new. Leave it as it is. Gonna change this to just / evaluation order 1, and also this just to /. Yeah, everything looks good. So go ahead and click next step. Yeah, next step, and create service. And it might take a little while before it actually starts everything. But if we go ahead and navigate to EC2, we should see 2 instances running. Instances. Yes. And here are 2 instances running that we just created through ECS. So the next step now is to create our pipeline. And create pipeline. We're gonna allow it to create a new service role for us, and this is gonna be the name for it. Just gonna go and copy that. Next, source provider is gonna be CodeCommit. We're gonna use the repository, YouTube, master, and the rest of this is just gonna be the default ones. Build provider is gonna be CodeBuild that we just set up. Make sure that everything is the same region, of course. Just gonna go ahead and add that and click next. Deploy is gonna be ECS. We're gonna choose our cluster here, choose our service, and we have to add this image definitions.json file. Image definitions. Okay, yeah. Next. And create pipeline. On the first run here, it is gonna fail. First of all, we haven't pushed up the image definitions file. Secondly, we haven't also given the permissions and policies that this newly created role needs to actually build and deploy this. And also, there is another step we need to add is that this is gonna create a bucket for us, which is gonna store a bunch of artifacts. CodeBuild is going to need access to that bucket that CodePipeline just created for us. We could have gone ahead and created that ourselves, but it is just way easier to let AWS do that for us and then just fix everything later on. I'm just gonna let it run, I guess, and we can go ahead and go to IAM. Just gonna attach those policies and permissions. Roles. Yeah, here it is. Then it just created permissions, attach policies, and then we're just gonna give it S3 full access. Yeah, we go ahead and attach that policy. And now we also need to actually, did I add it? Yes, I added it. So we just need to push this to the repository. There we go. And we need to go to pipeline and no, wait, here, CodePipeline, pipelines. The YouTube pipeline. Oh, never mind. Here's the edit button. And then we go to deploy, edit stage. We can edit deploy. And when it comes to action, no, not action provider, input artifacts is gonna be source. And yes, that's all. Go ahead and click done, done, save, save. And now we need to go to CodeBuild. Edit artifacts. Amazon S3, bucket name, and this is the bucket that CodePipeline just created for us. We needed to create the CodeBuild first, because otherwise we can't choose what it is going to use for building in CodePipeline Wizard. But we can't create the pipeline first either, because then we don't have the bucket. So it's just easier to let it fail and then add everything later. Actually, it's gonna call it YouTube build output. Let me think now. I think with this slash. Yes, it's just slash. And it's gonna be saved as a zip file. So make sure that is checked in, and update artifacts. We also need to, we actually could just redo this whole thing and let it run. While it does that, we have to basically that our containers can reach any, can't be reached by anything except our load balancer. So no IP addresses, like everything is going to be blocked except for the load balancer that we just created. So I'm just gonna, we have to go ahead and go to, let's see here. Security groups. Here we go. Yes, and we're gonna go to this security group that is for the ECS containers. We're gonna edit the inbound rule here. So we're gonna delete this one. It's gonna accept what's it called, all traffic from YouTube security group, and the only thing that is attached to this security group right now is the load balancer. So we're gonna accept all traffic that is coming from this load balancer, basically. Save rules. There we go. Okay, successfully built now, and let's see how it goes with deployment. This can actually take a really, really long time. If it doesn't fail immediately, it basically means it's like a 99% chance that it actually is successful. And we can actually already see that the result right now, but it won't get a green mark until maybe like in 20-30 minutes or something like that. It can take a crazy long time, even though the whole deployment happened in 2 minutes. And not sure why, but that's how it is. And we can gotta get DNS for the load balancer. There we are. Yep, here it is. And if we open a new tab and go to it, it should so anyway, moving on, we can now I'm just gonna prove that this load balancer is actually hitting 4 different containers. Let's see. Let's see here. Right, I need to add the security SSH as security group for this. Right. There we go. Here we are. Then we can get the other IP address. Okay. So now if we run docker container ls, we can see that there's gonna be 2 containers running here. Actually, it's gonna go ahead and zoom in a little bit. You can see better. So what I'm gonna do is edit the index file. In each container, and then we're gonna update the URL to the load balancer, and you can see it's gonna be hitting different containers. And now we're gonna do the same on the other instance here. Yeah. So now we're down here. So here we're in the server 1 and we are going to the container 1 and we're just adding that as a text to the index.html file. And then we do the same on another container, but just adding a 2 instead. And we're doing the same shit here, just adding a server 2 instead of server 1. So if we go to our load balancer and hit refresh, we see here server 1 container 2, server 1 container 1, server 2 container 1, server 2 container, oh well, 4 in a row, how good is that? And if we continue hitting refresh, it's gonna change dynamically to all different containers running in these instances. And now to the last step of the demonstration is to let's see here. Oh man, don't have access to the CodeCommit anymore. I'm just gonna go ahead and pause it and give me access to the CodeCommit repository again. So I am back now and I have created basically just another key and attached it to my actual local machine now. Before I was running everything in a Docker container for some reasons, and the Docker container died because I had a timer on it and I lost the key. So basically I had to recreate it. Anyways, now I can actually update the index.html file and we can change it from it works that we saw previously to something else, and we can have a preview of the whole pipeline. Yeah, that should be good. Right. Yeah. And now if we go to the pipeline, we should see this should kick in any second now. Let me just see that it actually updated. Yes, it did. Oh yeah, okay, now it's in progress. So it's building everything. Now when the build is complete and it is in progress of deploying, I'm just gonna go ahead and refresh this web page anyways. There we go. Build and deploy with CodePipeline.